Have you ever looked at a probability problem and just had that feeling like, this seems simple, but I know there's a trick here? Well, today we are cracking the code on one of the most common traps out there, figuring out the odds of one thing or another thing happening. Let's get right into it. So, here's our game plan. We're going to start with a puzzle. Then we'll build up our toolkit with two really powerful methods, two-way tables and Venn diagrams. After that, we'll learn the one rule you absolutely have to know. And finally, we'll put it all to work. By the end of this, you're going to be a pro. All right, let's kick things off with Section 1, the probability puzzle. Okay, so this is the central mystery we're going to solve today. Here's the question. If you pick a US teenager completely at random, what's the probability they use TikTok or Facebook? Now that little word or, believe me, that is the key to everything. And it's exactly where most people get tripped up. Now, here are the numbers we're working with. And I know what you're thinking. Your first instinct is probably just to add 63% and 33%, right? But just hold that thought, because as you're about to see, that leads you straight into a very, very common trap. So to solve this puzzle, we need the right tools. And our first one is the two-way table. It is just a fantastic way to get all this information organized. To get the hang of it, let's start with a simpler, different example. Okay, so let's switch gears for just a second. Picture a group of 200 college students. We're going to look at some data on two kind of quirky skills, whether or not they can roll their tongue and whether they can raise just one eyebrow. And boom, here's the table. This thing lays it all out so clearly. You see the rows? They show us who can and can't roll their tongue. And the columns? They show who can and can't raise an eyebrow. Those total numbers around the edges, they give us the big picture for each category. It just makes everything make sense. So using this, if we want to know the probability that a random student can raise an eyebrow, it's easy. We just grab the total for that column, that's 62, and we divide it by the grand total, 200. That gives us 0.31, or a 31% chance. Simple, right? Okay, what about the probability that someone can do both? Well, we just look for where the can roll tongue row crosses the can raise one eyebrow column, and right there you see the number 42. So 42 out of 200 gives us a probability of 0.21. All right, we've got the basics down. Now it's time for the main event, calculating those tricky OR probabilities and learning how to avoid that nasty double counting trap. So let's go back to our practice problem. What is the probability that a student can roll their tongue or raise an eyebrow? Now, this is where things get interesting. The really tempting thing to do, the thing that feels right, is to just add the probability of rolling a tongue, which is 149 out of 200, to the probability of raising an eyebrow, which is 62 out of 200. I mean, it seems perfectly logical, doesn't it? But look what happens when we do that. We get 211 divided by 200. Whoa, hold on, that's impossible. A probability can never be more than 1, or 100%. So something has gone seriously, seriously wrong here. What is it? And here it is. This is the whole secret. The problem is that we counted those 42 students who can do both skills twice. Think about it. They got counted in the can roll tongue group, and they got counted again in the can raise eyebrow group. We double counted them. And that brings us to this beautiful, simple solution. It's called the general addition rule. To find the probability of A or B, you just add the probability of A to the probability of B. And then, this is the key, you subtract the probability of A and B happening together. That little subtraction is what fixes the double count. It's perfect. So now, armed with our new rule, we can finally go back and solve our original mystery. What's the probability a teen uses TikTok or Facebook? Well, we just plug it in. It's the probability of TikTok, 0.63, plus the probability of Facebook, 0.33, minus the probability of using both, which is 0.22. And there we have it. The answer is 0.74. There's a 74% chance that a randomly picked US teen uses either TikTok or Facebook. Mystery solved. Now, we solved it with the table, and that's great. But there's another amazing tool for this kind of problem. A two-way table is fantastic for organizing the raw numbers, but a Venn diagram, that's perfect for actually seeing that double-counted overlap. And look at how these two tools are just perfectly connected. The four main cells in our table, they map exactly to the four regions of a Venn diagram. Those 42 students who can do both, they go right in the middle in that overlapping section. The 107 who can only roll their tongue go in one circle. The 20 who can only raise an eyebrow go in the other. And the 31 who can't do either, they just hang out on the outside. It's the exact same data, just shown in a different, more visual way. Okay, you've learned the theory, you've seen the tools. Now let's just build up some confidence by applying all this to a couple of new scenarios. Let's do some reps. Okay, check out this new table. It's got data on home ownership and college attendance for 500 adults. Now, if I asked you for the probability that a person attended college or is a homeowner, how would you do it? Well, you know the drill now, right? You take the total who went to college, add the total who are homeowners, and then what's the crucial last step? You subtract that overlapping group of 221 who are both. And here's one more, this time laid out in a Venn diagram. Let's say I ask, what's the probability a person reads exactly one of these papers? See how the diagram makes this kind of question so easy? You just add up the only parts. The 17% who only read USA Today, plus the 9% who only read the New York Times. That gets you a total of 26%. So there you have it. That's your complete probability toolkit. You know how to organize data with a two-way table, you can visualize the overlap with a Venn diagram, and most importantly, you always use that general addition rule for any OR question so you never fall into that double counting trap again. And that's our explainer. But really, the thing is, you're going to start seeing these OR situations everywhere now, in the news, in ads, in sports stats, you name it. So the final question I want to leave you with is this. Now that you have these tools, now that you know about the double counting trap, what common assumptions are you going to start to double check?